Look like much, and I apologize for the fan noise in the background. That's my power supply, and it may be a little confusing, but these LEDs are going to represent what the taillights will look like. So the first thing, I have some switches here to emulate what the car will send to the controller, and this will all make a little more sense in the next video where I actually have kind of a mock-up hook to the vehicle. But this switch represents the taillight. So I turn that on, my taillights will illuminate. This button represents my brake lights, 3 on each side. And then these are my turn signals. So with my brakes off, if I were to push the turn signal, you see it'll go through 1, 2, 3, and then this blue LED at the end represents the side marker, which will stay on for 2 pulses. And because it is through a separate output, it's totally programmable. All of these are optically isolated, and then they go through these Darlington transistors. Actually, these are MOSFETs. They go through the MOSFETs. Darlington optocouplers, MOSFET outputs. You can see left and right. If the taillight is on, it will turn the taillight off on that side and then cycle through, and that'll make more sense when you see the actual lights. If my brakes are on, then the way it works is the reverse. It's whatever gets lifted, because the change of state now is not turning on a light, it's turning off a light. So same type of deal applies. You can see it goes through the cycle. My brake lights. So anyway, the next video that I'll have out will actually have the kind of the lights in general. The lights look like this. They have an outer ring and an inner piece that are independent of one another, and it'll kind of make a little more sense.